Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to another episode of the Reliability Matters podcast. If you're part of our podcast family, welcome back. And for those of you keeping track, this is episode number 127. I'd like to begin by expressing my gratitude to my listeners and viewers of this podcast. Our listeners and viewers have downloaded episodes of this podcast more than 35,000 times. When we add downloads from our syndication partners, that number jumps to over 80,000 downloads. Speaking of syndication partners, a special thanks to two of our partners who syndicate this show. A special thanks to Mike Butow of Circuit Assembly Magazine, who syndicates this show on PCBchat.com, and to Fred Schenkelberg of Ascendo Reliability at reliability.fm. Fred curates a number of reliability-based podcasts, including this one. In recent episodes, we've covered high-level issues such as hiring best practices, novel training methods, design for manufacturing, highly accelerated life testing or HALT testing, and much more. On this episode, we're going back to the basics. What common problems are assemblers experiencing today? What are the basics of electronic assembly best practices? Which problems seem to live in perpetuity? To answer these and other questions, I've invited back two of my favorite experts onto the show. If you've been in the electronics assembly industry for pretty much any amount of time, there's little doubt you've heard of Phil Zarrow and Jim Hall. Phil has been involved with PCB fabrication and assembly for more than 36 years. Phil is the president and principal consultant of ITM Consulting. Jim Hall has been involved in the electronics assembly industry for the past 27 years. He's a principal consultant and resident Lean Six Sigma Master Black Belt with ITM Consulting. He's also an instructor in the Lean Six Sigma programs offered at Dartmouth College. Together with Dr. Ron Lasky, Phil and Jim designed the Surface Mount Technology Association's SMT Process Certification course. More information on that valuable course is available at smta.org. A couple of years ago, Phil and Jim published a book entitled Troubleshooting Electronic Assemblies, Tales from the Board-Talk Crypt. I'll talk to them about this book later in the broadcast. Phil and Jim host the popular audio series Board Talk, a question and answer show hosted on the Circuit Insight website. On their show, you'll hear serious questions and often comical but real answers. A heartfelt welcome back to my friends Phil Zarrow and Jim Hall.
Hey, Mike.
Hi, fellas.
Hey, Mike.
Welcome back.
Thank you. Good to be back.
It's good to have you. So the last time we spoke, you guys were quite busy solving problems. Have all the problems been solved?
Oh, absolutely.
All done?
Yeah. We need a few more. We need a new technology or invention to kind of throw some loops. Yeah.
Well, if that's true, this might be our last ever Reliability Matters broadcast.
Yeah. We believe that
something tells me that by the time you guys win the lottery, buy an island in Tahiti, and go retire there will still be plenty of problems. And something tells me they're not going to go away.
Yeah. Good point, Mike.
So before we dig into problems and solutions and all of that, for those few who are unaware of who you are and ITM Consulting in general, share with my audience a little bit more information about ITM and what you guys do.
Okay, we're consultants, which sometimes people use consultant for employed with a briefcase, but we're a little bit more sophisticated than that because this is how we make our living. Essentially, I think one of our literature were described as dealing with electronic assembly. And we deal with all aspects of the assembly process. One of our specialty things is process audits, which we've been doing for really over 30 years. Refined our technique, and we do it for certainly as a process failure analysis. Nice way of saying troubleshooting method of operation. But we also do it. We're inviting by customers who want to improve the process. We seem to be doing okay, but what could we be doing better? So that's one of our hallmark things. We have 2 patents on our process methodology. We also do a lot of we call, again, process failure analysis, which we otherwise known as troubleshooting. But basically, a failure analysis lab will tell you, yes, you have head and pillow, or yes, you have this. We're the ones who will go out, look at your process, and basically explain why and what you can do about it. So things like that. And of course, we do education. We do a lot of conferences, workshops, at all the biggies, and also for customers. Sometimes I was in to do workshops and kind of customize it for the particular customer. Anything to add to that, Jim? Put on your glasses, so I figured.
I just want to emphasize training, because that's what I do most.
Right.
We offer training in basic technology of assembly and also best practices of current technologies, new technologies. And we offer those in public forums. We always speak at Apex and SMTA and so forth. But we also bring these in-house and tailor them to the specific needs of specific customers, or training their in-house people for the specific problems and advances and developments that they're working on.
So, Jim, also you're involved. I know both of you helped create the SMT process certification course. And Jim, I believe you're one of the instructors for that course.
I'm a
Explain
primary
to me,
English language instructor, yes.
So explain to me what that course is, what types of people take it, what does it do for those who manage to pass it?
Well, that's important, passing it. It has a very serious exam of essay problem-solving questions, not multiple choice. That's one of the foundations of it. It is truly a certification for people who are experienced and want to get, a shingle or a placard to say, hey, to show to other people, I am knowledgeable in all the basics of the entire process.
So it's not just a reflow process or a printing process or a soldering process. It's the whole process.
Materials, processes, and so forth.
And I would imagine as electronics have evolutionized, that course is kind of a living course. It must change from time to time to reflect current technology.
It does, but we still try to emphasize the basics. We emphasize it's not an advanced technology. You don't have to prove that you know the latest phrase. What you have to prove in the exam, through the exams, is that you understand the basics. Our philosophy is that there's always new problems. Tomorrow there's going to be another new one. But the bigger and the more comprehensive your foundation is, then the better you are prepared to deal with the new thing that we don't know about yet. And so that's the way we run it. We go through the whole process, starting from very basics. We take a day and 2/3 to go to review the entire process, from materials. We do a basic unit on soldering. One of the best parts of it, I think, Mike, is stencil printing. Now, we all know that stencil printing is one of the most important processes because it generates at least 50%, probably more like 70 or 80% of all the defects we encounter. Now, if you think about it, it's 3 things. It's a printing machine, a stencil, and solder paste. 3 different things you buy typically from 3 different vendors, and you've got to make them work together. So what we've done is, and some of you typically get information from the solder paste people, information from the printing sheet people. And they, of course, have their own slant on it, the way they present the material. What we've done is unpackage all that material, and present it in what we think is the most logical way to get the best overall view of the process and the many interactions that control the ultimate quality you get out of it.
Yeah, it sounds like quite a valuable course, probably good for one's career as well. I mean, talk about a shingle, right?
It's something that'll look good on your permanent record.
That's right. I just did a SMTA update. Every month I do an update on events that are coming up. And of course, this month, by the time our audience sees this, this will already have happened. But I know there's a certification course coming up in Mexico in the next week or two.
That will be in Spanish, taught by our Spanish language instructor, Ian Castellanos, who is works for India, and he does our Spanish language courses.
Right. Yeah. And there's 3 or 4, as I recall, of these courses spread around the country. And in order to take this course, the course is offered, although you are one of the instructors and the two of you are 2 of the contributors to the course, it actually is offered by SMTA. So if someone is interested in taking this course, you can go to smta.org, as I'd mentioned in the intro, and get more information on that. I had mentioned that I just in the update, and part of that update was explaining a little bit about the course. It seems to be a 2-day course, half day
3-day
of 3-day. Okay, so 1 full day of a day and a half of instruction and a day and a half of testing. Thereabouts.
The first day is all instruction. I like to say it's a review. It's a review of what the people should know. I mean, theoretically, an experienced process engineer should be able to come in and take the exam.
Mm-hmm.
But the reality is, few of us, haven't been many comprehensive basic training programs for SMTA, for electric assembly. So you learn the way you learn your word processor, right? You learn what you need to know to do solve the problem today. So many people, although they've been in the industry, there are gaps. They haven't worked a lot with tests, or they haven't worked a lot with dispensing or things like that. So I think for most people who come to the course, it's an opportunity to fill in the gaps in their experience. And so again, it's not advanced, but to learn the basics of all of the steps in assembly.
And speaking of basics, polish up your algebra, because from what I understand, there's quite a bit of algebra involved. You have to not just come up with the answer, you have to show your work in some cases. Is that correct?
Correct. That's correct.
Yeah, which it's also, we want to note that from its original inception, it's not multiple choice. And, as a lot of other courses are, you have to know it. And it's based on, as our co-author of it, Dr. Ron says, you're on a manufacturing floor, you have a problem. God doesn't send out a billboard and say, choose A, B, C, or D. You better know what you're talking about.
Right.
So,
the only time you get a multiple list from God is the 10 Commandments. And none of those are optional, right? That's 10 out of 10.
Little course in that too. The 10 Commandments of electronic assembly.
Right.
But,
well, even someone who is not familiar with electronics, if you had multiple choice, they're going to have a 20-25% chance of getting it right.
Yes.
Right? Yeah, Jim.
And I got
Mike, I want to finish up the 3-day sequence. First day and 2/3 are this review. On the end of the second day, we take 2 hours for a closed book exam, which are simple, short answer questions, maybe a simple calculation. The entire third day, we do a review of anything the students want to ask. And then very early we start and we give the students about 7 hours to complete the closed book exam, which is 5 large problems that they have to analyze and solve. Most people take about 4 or 5 hours to complete that part of the exam. So that's the 3 days.
Yeah. Well, again, more information on the SMT process certification is available at smta.org.
By the way, Mike, Jim will be giving the course at SMTAI in October, and so this is a great opportunity. The guy, one of the co-authors of the course, it's kind of like going to a concert. Instead of somebody covering a song, you got the original artist. So you have the Bob Dylan. That's probably a bad analogy. Jim's still pretty coherent, but you get the idea. You get the original here, and you'll autograph your test.
Very good. What would you guys consider to be the perpetual problems, the problems that just won't die, that just won't go away? On this show, we spent the first 2 years of the show largely talking about voiding, and There were two trains of thought. We can get into this part later, but those that say voiding's a big issue, we need to solve it, we need to strive toward 0% voiding, and then there are those on the other end of the coin that are just like voiding's way overrated. It's not a big deal. You don't need even 70% coverage. You could have 30-40% voiding, everything's fine. So we've heard both opinions on the show, but that's just an example of a perpetual problem. What are some of the other perpetual problems that you see in your business that cause your phones to ring? Wave soldering.
Yeah, there you go. It's forever. Everybody wants it to go away. Everybody wants through-hole components to go away, but they don't. And as Phil can probably explain it better, it doesn't get a lot of press and a lot of emphasis, but it's still there. You got those few through-hole components you got to solder, and for large volume, you like to use wave solder. But because there isn't a lot of training, the experts are retiring, and so you get a lot of new people who haven't had a big experience because it isn't given a lot of press, and so we get a lot of questions on Board-Talk. A very high percentage of our questions are on wave soldering as one technology.
Yeah, I would think more and more. I would think that would be a more popular question today than 20 years ago or 30 years ago, because wave soldering went from
doing it was much more in-house expertise 20 years ago, because it was such a bigger part of your total assembly process. But now it's a small part, but it's still critical, like any other part. So, and yet you don't have this expertise is slowly retiring.
Right. The early days of surface mount, I recall. People were gluing them to the bottom side of a board and running them through a wave solder machine. But the early days of surface mount, as I've said on the show before, were basically through-hole components with the leads just, bent 90 degrees outward, right? They were not the surface mount we know today. Certainly bottom-terminated components cannot be glued to the bottom of a board and run through a wave solder machine. There's nothing to solder, right?
In fact, any multi-leaded component is very, very difficult because of the bridging problem.
Right.
Like a QFP with 208 going leads around there at even 50 mil pitch. The older way in the day were still very difficult to wave soldering without having massive bridging.
I started my career in this industry in 1985, working for a startup company with a novel soldering machine. It was not new technology, but it was a novel approach to this new technology. It was called drag soldering. Remember that?
Oh, yeah.
Sometimes referred to as dip soldering.
Yep.
And it was supposed to be the best thing since sliced bread for through-hole. And it was really good for through-hole. And because it could take long leads, you didn't have to cut your leads short. It had a 3-inch depth solder pot, so you could have leads hanging out as far as you want. They put technology in that would prevent bridging, and it was pretty good. The problem that I had was I entered the industry at the very beginning of surface mount, at the very beginning of the obsolescence of this new technology. So, I was like the guy that came up with the latest design of the horseshoe right around the time Henry Ford came up with a Model T. It was just bad timing. But I would think 30 years ago, most boards were soldered in a wave solder machine, so that was the conventional technology, and surface mount was new. Everyone was trying to figure out how to do surface mount. Now we kind of have the opposite problem. Almost everyone is experienced with surface mount, and fewer are experienced with through hole.
Exactly.
So it's just problem turned on its head, right?
But the problem, Mike, the problem
with
as Jim is explaining, with understanding, comprehending through-hole technology. Yeah, we've had improvement equipment. We've soldered selective soldering. We have a lot. We have to be big of intrusive soldering, pin and paste. But what Jim's saying, this evaporation, the tribal knowledge, is symptomatic of, I would say, probably one of the biggest problems we have in our industry. And the corresponding to that, where do we get good talent? That is the biggest problem. That's a problem we hear wherever we go, whether it's a CEM, an OEM, whatever country we go to. Where do you get new talent? Where do you get people to operate, not just as engineers, and thank God for STEM, but we need more engineers and the technician at the technician level. I mean, a number of times I'd recommend, why don't you guys set up a kiosk in the student union, the local community college, and grab them as you can. But this is probably one of the biggest problems. As us guys with tin whiskers are slowly fading away, who's going to run your process. So I'd have to say that's the biggest problem. We hear it everywhere we go.
Yeah, phenomenon often referred to as the silver tsunami, right, or the grain out of our industry. And that is a real problem. We've talked about it on the show before. Subject matter experts that work in companies are retiring, and they're not being replaced by single subject matter experts. I've talked to Doug Pauls on this subject, and obviously he's working with a protege, Doug Pauls from Collins Aerospace, formerly Rockwell. He's the cleaning conformal coating expert for the entire company, and when he goes, as much as he can train the new person, when he goes, a lot of the process knowledge, a lot of the knowledge of where all the process skeletons are buried, go with him. And a lot of companies now are not embracing, I'm not saying Collins is, I'm sure they are, but other companies are not really embracing having one person whose total job is to know one thing very well, right? And unfortunately and fortunately, that causes two reactions. One, the unfortunate one, is who do process engineers go to or technicians go to for advice? They go to vendors. As Maslow said, if all you have is a hammer, all you see is a bed of nails, right? And if you talk to a cleaning person, for example, every problem can be solved by cleaning. If you talk to, a thermal management company, profiling company, every problem is going to be a better profiler, right? Every solution to a problem is going to be a better profiler. Right. So you're kind of having, a fox in the hen house scenario. On the good side is it could drive more younger engineers to conferences, to hear the experts speak. It could cause younger engineers and others to go to consultants like yourself and others to seek advice before you guys join the silver tsunami and leave. It's good for the show. This podcast was done for this reason, just to memorialize all the best practice information before y'all retire,
To that point, Mike, all three of us are participating in organizational things to produce sustainable training programs, passing on some of this knowledge, both too many, but I know we all work through the SMTA and their training programs, their one-on-one programs. In fact, Mike, you created the first 201 program in the SMTA training program.
The first 201 training course. And the reason why is because all problems can be solved by cleaning, Jim.
Right. And I'm in the process of doing one with Chris Shea and Ron Lasky on how to do a design of experiments. And of course, everything can be solved with a design of experiments, the same thing. Right. Also, Bill and I are working with the IPC to create a training course on troubleshooting. Again, that will be sustainable, that will go beyond us.
Yeah. All that is a reaction to the current situation, which is the aging out of our workforce, the too slow emergence of new engineers stepping up. And when someone graduates a university, they have a good understanding of how electrons work. They have a good understanding of electrical circuits. They don't probably, unless the university has a really good working lab and they spend a lot of time in it, they probably don't have a good understanding of proper squeegee pressure or the difference between an MPM printer and a deck printer or whatever, or certain types of cleaning agents and best practices for checking concentrations to keep it in the cleaning world. That's not really taught at a university level. That's way down a rabbit hole, and that is learned on the production floor.
Right.
From people who know. And when those people who know leave, that leaves a big void. And that unfortunately puts the burden on, not so much a burden, but it puts the responsibility on the suppliers who look through the world with a very narrow lens, right? So, a little bit of a polarized and a polarized lens. That could be good information. It could be partisan information. We just don't know. What are some of the key factors that?
I just want to
Yeah,
hit
go ahead, Phil.
one of the other things, the passing of the guard, so to speak, is, kind of going back to how we got to where we are. History sometimes repeats itself, but knowing how we got here. For example, the fact that, any automotive OEM or CEM you walk into these days, people are using gloves. The gloves. Where does that come from? Well, I always like to give the anecdote about Terry Munson's study when he was at Delphi. He was shower effect and other things. Of course, it was a rude awakening. I think we were team teaching at the SMTA or Apex a couple of years ago, and I was citing a study that was done by, I think it was done by ATT North Carolina back in mid-'80s on inspection, about visual inspection and the subjectivity of it. And I'm going, but you guys, boards were a lot easier back then. You guys remember, largest component we had, smallest component we had was an 0805. They didn't have PTAs yet. Things were easier. Jim goes, Phil, none of these people in the audience were born in 1985. So, oh God, man, that was sobering, Jim. I'll tell you, man. What do we become the old men in the room?
I know, right?
It's just
right.
something. So there is something to the history, as you well know. The three of us were lucky to have been involved in electronic assembly at the inception of SMT. So we've seen the whole story. So talk about being in the right place at the right time. But
Sure.
Yep, but time marches on.
That's true. You mentioned an example about gloves. I have a theory on gloves, and I think given the choice of how gloves are currently used today, I would prefer people not wear gloves to wearing gloves the way they're wearing gloves today. And what I mean by that is, if I'm picking up a board just to inspect it, and I don't have any gloves nearby, I am holding it by its edges. I am not touching the face of the board. I'm a contamination expert, right? So I know what happens. But I'm really, really careful about how I handle that board. If I'm wearing gloves, I'll manhandle that board, no problem. I can't tell you how many times I see people take their gloves off, put them in their dirty smock pockets, go to lunch, come back, put the gloves back on. Hands get washed several times a day for most people. Gloves never get washed. Gloves are supposed to be disposable. Every time you take them off, they should never be put back on. But I can't tell you how many times I've seen people reuse gloves over and over and over and over again. And, you may not transfer skin oils by doing that, but you will transfer everything else those gloves have touched. So my personal preference is, unless there's there's an attitude of and a practice of throwing out gloves every hour or whatever, every time you take them off, never reuse them. I'd rather see people hold them more carefully with their bare hands than sloppily with dirty gloves.
Pursuant to that, Mike, anything else that touches the board, like fixtures, test probes, and everything else, also can potentially become sources of cross-contamination.
Yeah. An anecdote for that. The first year SMTA, back then SMTA and IPC produced the high reliability cleaning and conformal coating forum, which, by the way, is coming up in next week. By the time everyone watches or hears this, it's already happened. Now it's an SMTA event exclusively. But the first time they had it in Chicago several years ago, someone from Research in Motion, otherwise known as BlackBerry. Remember BlackBerries? All the young kids are like, "What's a BlackBerry?" They made mobile phones, which at the time were as popular, if not more, than the iPhone. Right? It was the phone of choice.
Well, they were before the iPhone.
They were before the iPhone. The iPhone killed them, obviously.
Right.
But
Exactly.
they had an issue where they had to clean. They had to clean, and there are certain people who just don't have to clean. If you're building 10 million, 20 million, 50 million of the same thing every year, you can design out certain, the economy of scale, the scale itself is so great that you can spend money to design out a process and save money. The anecdote, I don't know if it's true, was, 1 year American Airlines took the olives out of the martinis
I remember
that they were serving in first class, and they saved X amount of dollars a year in fuel, by having to carry the extra weight. American Airlines decided for many years not to paint their planes. They just
Right.
put a decal stripe on it, and it was basically shiny aluminum, on the
Yeah.
plane. And they did it because it saved weight and it saved fuel.
And in their infinite generosity, they passed it on to the passenger, the consumer.
Yeah, right. Yeah. And
Was
fares
yeah.
plummeted.
Yeah.
But BlackBerry had to start cleaning certain parts of their board. Now, why? They were a strict no clean, and even today, I think iPhones and all the others are pretty. I'm pretty confident they're all no clean. But they had a contamination problem, cross contamination problem. To your point, Jim, they had silicon mold release that somehow got on a component, and they couldn't solder to it. Right? They couldn't solder to it. If you want to punk a friend, put a little Vaseline on a solder joint and watch the solder just get repel. But and they discovered
that down like, okay, good.
yeah. They discovered after an investigation that the silicon mold release came off the component reels. When their component reels have to pop out of a mold, they use mold release, and there was too much mold release, and it transferred to the component and caused a problem. So they had to rescue clean a whole bunch of components so that they could use them, and then they fixed the problem. But it goes to show, to your point, the common the ability for anything in your factory to transfer to anything in your factory. It's not just humans.
Right.
What are some of the key factors that influence reliability of circuit assemblies in general? What do you consider? You've mentioned already, Jim, printing being responsible for 20 or 30% of all process issues. I've even heard numbers even higher than that. But what other types of factors influence reliability?
Well, if we take real long-term reliability, Mike, you're down to the durability of your solder joints. And of course, getting the right solder paste, so forth. But really good, fully documented reflow profiles is really important. Making sure that all the solder joints on an assembly are seeing the proper time temperature. And whereas if you don't instrument it and use profiling procedures, they pretty much inspect, but you might have a number of solder joints, like particularly the solder balls under a large BGA component. You don't actually put a thermocouple under there and measure them. You're not really sure that they absolutely got to the proper wetting temperature. They probably got close, and they created an electrical connection, but they didn't get fully processed. So maybe they have voids, maybe they have marginal wetting. So the board works, but then long term they fail before you want them to in real life. So that's certainly an important thing.
Yep. And
Bill, what do you see?
Keyword, but cleanliness also, obviously, and wow, you could do several webinars on podcasts like cleanliness, Mike. But where people are taking a closer look at what is clean, what isn't clean, what's the effect on things like conformal coating and eggs reacting, no cleans reacting with the environment, clean, no clean. So cleaning obviously a lot more attention than say 10 years ago, I think, in terms of reliability.
Yeah, Jim, to your point about thermal profiling, our friends and colleagues at Foresight and us produced a DOE a few years ago where we ran test coupons,
I read those
Umpire
results.
2 boards, and we purposely ran various profiles, and we ran the recommended profile, peak reflow temperature profile, and then we lowered the peak reflow temperature below the recommended amount by just 5%. We can vary 5% day to day in a manufacturing process. We lowered it 5%. The boards that were at the proper reflow temperature, and they were reflowed with a no clean solder paste, they passed 168-hour surface insulation resistance tests. So they were considered by IPC standards as very clean. The same boards processed at 5% lower temperatures failed all the SIR tests. Not just for solderability. I mean, we think about reflow temperature so we get a good solder joint, so we avoid cold solder joints and other failure modes. It also influences the residues that are on a board, particularly with no clean, because no clean is supposed to be, all the bad actors are supposed to be burned off. And when the peak reflow temperature is marginally low, those bad actors are staying on the board, and they're going to do what they do. They're going to create dendritic growth and electrical leakage and all sorts of nasty things.
Okay, Mike, we've been having a cleaning perspective. I'm a reflow guy. The reflow perspective, pursuant to what you said, 5%, you should test your reflow oven to find out what its repeatability is. Find out when you run the same boards, the same profile, or if you use one of these test things like an oven rider or something like that, you should run it multiple times under different typical process conditions, loaded, unloaded, and so forth. See how much the peak temperature varies, right? And is it 5%? Is it 2%? And then you should include that when you set up the tolerance on your specification, on your profile specification, to allow for that. Saying, okay, I'm going to run this profile because every time you profile a board, you're not going to run it 20 times to see the repeatability of that profile. You got to know what the repeatability of your oven is, and assume that's going to be similar over most boards, and then apply that to your spec and say, okay, we're going to get this, but we're going to measure on a one-shot profile a certain temperature, but we know in real life that can vary. So we're going to set that in the specification of that temperature to allow for that, so we're still in that good range where we won't get these bad results that will affect reliability.
Agreed. What industry standards do you typically rely on when you're consulting with a customer or doing some kind of investigation or training a customer? Are there specific go-to standards that you use to compare what the customer is producing versus what the industry says they should produce?
Well, obviously the old standards, which everybody has is of course IPC 610 and JSpec 001, probably the standards. And then we like to see people informed about 1602, which of course deals with moisture sensitive devices, things along those lines. And then of course there's the specific specs. We're working with ENAVE, there are specs that correspond to that, and we'd like to see that. But so much of what we have, I think one of the problems is people are always looking for a spec as holy scripture. And in reality, so much is what we call best practices. They're not yet specifications. They might become specifications, but it's what's been found by industry practice to be, the best solution at the time with what we have and what we're dealing with. And that's quite frankly, basically what our process audits are all about. Sure, we'd like to see adherence to, specifications, like to see they're handling things properly. If you are wearing gloves, still you have to hold the board by the edge. Thank you very much, Mike. And but things like that. But the other is best practices. So with our audits, what we do is in results we have we have 3 levels of recommendations. We don't assign weights like that. I know a lot of people who audits do that. We just found out it still turns out to be subjective. So basically what we do is we have 3 levels of recommendations. Level 1 is do this or die. This is definitely affecting your yields, affecting the reliability of the product. You've got to rectify this. Level 2 is probably the mainstream one. And yes, you're doing it this way, but industry best practices, you might be doing a lot better, if you do it this way. Yep, it's work better if you use best practices. And so that's really the crux of what we're doing. And by the way, to add to what we discussed before, Jim mentioned reflow. My cleaning, I have to look back at print the excited paste deposition, and it's still, as Jim said in the outset, we're anywhere between 50 to 85%. Now we walk into places where 90% of the defects are coming from printing. So it's still there's a lot of operator interaction input, proper DOE must have been done, but we're getting better at it. And I would say that, one of the things very happy to see is over the last 30 years, the acceptance and the embracing of SPI, solder-based inspection, automatically. We're seeing more and more of that. We did a survey for market analysis many, many years ago, 30 years ago, and we found like maybe 7% of the industry was actually doing any kind of solid post-print inspection, and most of that was human. And now, Jim, what would you say in terms of SPI? Running the range of SPI, maybe 80%, 85%.
It's getting there, and the people who don't have it tell you, "Oh yeah, we're getting that next year."
Yeah.
And just for the very small percentage of my audience who don't know what SPI is, you're talking about solder paste inspection.
Right, post-print inspection, correct.
Standalone, after print, inspecting all of the joints, all of the deposits on the board for volume, height, and shape.
Yeah.
I want to go back to one thing, highlight one thing about specs that Phil talked about, and that is J Standard 033, the one that defines, controls moisture sensitivity and exposure of our mostly our IC components. Your IC components are mostly a molded black plastic, and that's hygroscopic. It absorbs moisture from the atmosphere, and if you leave them out of the moisture barrier bags for too long, they can absorb too much moisture, and when you go to reflow them, they damage the internal structure of the component. From all our audits, this is the number one problem. People who don't have an airtight moisture sensitivity program, meaning that according to their rules, there are possible scenarios where their components can be overexposed and they won't know about it. And as we all know, we all know about popcorning, with component actually cracks during reflow. That's actually a good thing because it happens. What people don't talk about enough is the lower levels of damage internally, like delamination, cracking of wire bonds, that may not get picked up in the assembly facility. The product may work, may pass tests, but you get out in the field and you get intermittents, things like that. And because we don't fully analyze all failures in the field, we really don't have any idea of what percentage of field failures are created by moisture-sensitive damage that slipped through and got out into the field and worked for a while and then had a problem. So the answer is to follow J Standard 033 and really control your moisture expenditure. It's clearly laid out time based upon the moisture sensitivity level, and you have to keep them in the bag or in a dry box for all the time before they go through their final reflow step. You're doing double-sided reflow, you got to worry about those components on the first side that now sat around for a while you were assembling the second side. Now they go back in the oven.
In addition to the J standards,
1602 on boards, you got to handle those boards same way. They're basically moisture level, MSD3 type components. But sorry, Mike, didn't mean to interrupt that.
No. That's in addition to the J standards that you were referring to on moisture-sensitive devices. The MSD Council, Moisture Sensitive Device Council, is another good resource as well. The proliferation. Let's talk about EVs for a moment. Do any of you have an EV or a hybrid?
I have a plug-in hybrid.
Plug-in hybrid. So this doesn't really
diesel, but I'm an outlier.
The good thing about plug-in hybrids is they're really designed to be plugged into a 110 outlet because you're not trying to get 300 or 400 miles of range on a battery, right?
I get 25 to 30 on one. It takes 5.5 hours. I just plug it in overnight, and if I don't drive more than 30 miles, I have an all-electric car. Right.
So this doesn't apply to you, but for those who opted for just the plug-in, not the hybrid model, they're seeing, with the exception of Tesla seems to be doing something right in terms of their charging stations, but the public chargers, the Charge Americas of the world and others, according to published accounts, at any given time, up to 25 to 30% of those chargers are broken. They're not functional. Part of it is, stupid human tricks. Part of it is vandalism. People drive into them, things like that. That's not really a design issue. But a lot of it is a design issue. They're placed in harsh environments, but they're not built to Class 3 standards. And although they should be built to Class 3 standards, not because people die if they fail, like maybe in aviation or medical, but because they just won't work unless they're built to a higher level of standard to incorporate the intended climactic environment, the harsh environment they're going to be operating in. What's your take on the, I'll make it a broad question, on the electrification of cars, the amount of electronics that are now in cars, even internal combustion engine cars, ICE cars, and the proliferation of IoT, Internet of Things in general, where we're putting electronics into things that formerly never had electronics and quite frequently don't need electronics. We're doing it because we can. There's a entry into the electronic assembly world from people who were not formerly in the electronic assembly world. And what's your take on that? What types of lessons can we learn from that? What issues do you see, if you see any issues at all in your world? What types of issues do you see with this new business sector of IoT and the EV world?
Well, I guess right off the bat, one aspect in IoT that kind of I'm apprehensive about is that we see IoT, whether it's in cars, with our factories, our assembly lines, we're seeing more and more of it. It's wonderful. Yes, unfortunately, there's a lot of bad players out there, and I'm just waiting to hear about somebody's assembly line or factory, that got hacked and are being held for ransom. Hey, it's probably happened already. We just haven't heard about it. So we're kind of walking that territory. And the other is, with regard to the functionality of the technology, it's evolving. It's getting there. It's not there yet. I heard a story the other day somewhere in the Bay Area where they had these autonomous taxis. And all of a sudden, there were like 30 of them, 30 of them. They just stopped. Usually in intersections, causing a lot of aggressive thoughts towards, this type of thing. They just stopped for about 15, 20 minutes. Then they started up again. They just stand there and their, lights would flash, the horns would beep. So, we're not there. But I'm more concerned about our vulnerability using these things. And again, technology for technology's sake, as you said, Mike, so much of that these days. We got to do this, we have to do that, and yet there's no really good reason for doing it. So, I guess I'm just an old folk.
I'm glad you brought that up. That's a good segue. In about a month, I have a guest on the show to discuss IT securing your network best practices. Now, that's not normally a subject for electronic manufacturing, but it should be, because in the world of Industry 4.0, every machine is talking to every machine. And
that's right.
If one of the machines has a vulnerability, say they have a software program that's really sloppily put together, and your network has a little bit of sloppiness built into it from a security standpoint, one machine can be a portal into your entire network. And, you shut down a reflow oven, you shut down the whole line, right?
Right.
Everything is linear. So any one of those assembly blocks removed from the process shuts down your whole line. So it's a major issue.
Mike, years ago, I read a study that a simulation that was run. They simulated a smart electrical grid with street lights and everything else, all controlled with IoT. And they set it up on a computer for a simulation. And, they thought they had a reasonable simulation. And then they put a virus in one light bulb, in a street light. And I think the simulation said in 15 minutes, the entire grid was dead.
Wow, that's a little scary.
Back to the manufacturing part. And the first thing I think with a lot of these IoT devices is, just as you said, you have to really think about how harsh the environment they're going into and how much you're relying on them. Phil did a project with IoT-controlled sprinkler controls for a golf course. And, little electronic things they did they measured moisture sensitivity, I think, and all this good stuff to, optimize your watering the golf course. But they had problems and bad things happen.
We are just about out of time, and I have pages and pages of questions here, so we're going to have to do this again. But I do have one more question. Troubleshooting Electronic Assembly Tales from the Board-Talk Crypt, a book that you published a few years ago now, I believe.
Yep.
You were kind enough to send me a copy. I didn't bring the copy into my studio, so I'll put it up in post.
I sit on this. That's good enough. Yeah.
No, don't you never on the shelf right behind you?
Yeah. I'm sure he's got.
It's not back there. Yeah.
That's all of them right there, right? If you want to buy one, he'll take one off the shelf, put it in a box. How's the book doing? And any kind of interesting feedback from that book?
Yeah. People read it. They find it a good reference. It's Shameless Commerce Division here. That is basically, as far as we know, it's the only book, and certainly a contemporary book, on troubleshooting, on the topic of troubleshooting. And it has a great cross-reference, index, and it's just a really great reference book, but it's also good when, you're sitting on the loo and, want something to read, and, it's interesting because it's in our style. And the way it came about was we were doing some board talks a couple of years ago, as you say, 2 or 3 years ago. And all of a sudden, we were looking at the episodes, and it turns out we'd been doing it for 10 years and over 200 episodes. And it's like, time flies when you're having a good time. It was absolutely amazing. I was just totally surprised. And so since the transcripts existed, we spoke to our publisher, Jeff Ferry, and we made a book. And it seems to be, I think people really like it. And, try it, read it. You'll find it handy, and it's affordable too. It's a good resource, like I said. So we've heard good feedback, and it's coming along. I wouldn't say it hasn't made the New York Times bestseller list yet, but we hold out.
It's quite a niche market, right?
Yeah.
It's not a murder mystery.
It's a little bit more esoteric,
Although in some ways it's a murder mystery. Some people do murder their boards.
Some people do their circuit boards. Yep.
Yeah, and you guys are kind of like the CSI, crime scene investigators, right? Figuring out, who killed so-and-so with a hammer in the pantry, right?
Yeah.
Your clue. Each of you, this is the last question, share with me your funniest either anecdote from the book or from your board talk, your audio program that's on Circuit Insight. What's one of the funniest stories that someone presented to you? You model your board talk show after the long-running NPR car talk show. You have a very similar style where you make a lot of jokes and you have fun with the question and ultimately you provide sage answers in a unique comical way that only you two can do. But what's some of the funniest stories that each of you share? One funny story or very interesting story from your board talk experience.
Well, I'll go first.
Okay.
We had one that basically said, what do you think about putting weights on your BGA component when they go through the reflow of it? And what was happening is they were getting opened, I assume, due to warpage and so forth. And their solution is we'll take a heavy piece of metal and put it on top of the component to hold it down while it's going through the reflow of it. And your question is, well, did you profile the board with that weight on it? And what other, that's a classic Band-Aid solution, right? What is causing the problem? What's the root cause? Is it components warping? Your profile is not shaped correctly. It's causing warpage. You got a solder paste issue or something like that. But, you can imagine somebody after the placement machine sitting there with these little weights, putting them on top of key components before it goes into the oven. I thought that was a pretty funny situation.
Classic. And Phil?
I guess the one that sticks in my mind the most was somebody asked us if it was okay to use Windex to clean their circuit boards. And, all the sophisticated, work and everything on cleaning and chemistries, it's the like Windex. I personally use Mr. Clean, but, it's like, it's the same thing. I put that in the same category, though, they asked about it, as people who use paper slicers for singulating the boards. And I always go to Walmart for my circuit board assembly equipment. So that's one that sticks in my mind the most.
That reminds me of the movie My Big Fat Greek Wedding. One of the characters in the movie, the main character's father, his solution to everything is put Windex on it, right?
Yeah,
And in the movie, it always worked. So I guess that's the difference between art and life. My favorite was not, I didn't have this experience personally, but one time, when you go to trade shows and conferences, you tend to, go to a bar afterwards and you tell your, foxhole stories to everybody, life on the road. And I was talking to someone who sold a semi-automatic stencil printer. And, it was a pneumatic machine that ran the squeegee blade. No electricity, 100% pneumatic. And they got a call from a customer that the machine was leaking. And he said, leaking what? He goes, water everywhere. He said, well, I don't understand. Well, obviously, you can figure that out. The customer connected a water line to the air line. And every time and of course, air escapes, right? They have these little escape vents for the air, So every time you would normally run it with air and you hear that little that ended up being a spray event with water. And the customer was trying to figure out why it was leaking. It was leaking all over the place. And
the word was on hydraulic.
Yeah. That's when you have to pause and figure out a way to tell the customer without making them feel stupid,
It's outstanding.
There's really no way to do it. Just got to rip the Band-Aid off.
Yeah.
Well, Phil, Zarrow, Jim Hall, once again, it's been great to talk to you. We could do this all day. My audience is probably going, please don't, but I can do this all day. I really enjoy talking to you guys, and let's do it again.
Absolutely, Mike. We'll look forward to it. Sooner the better.
To my audience, if you need to get a hold of these fellas, they do have a lot of experience. They do a lot of work, a lot of really good work between the process certification course at SMTA and their consulting at ITM and other antics they get up to. I will put their contact information in our show notes. So if you're listening to this on your favorite podcast app, just go back to the podcast app, look at the show notes, and you'll see contact information for Phil and Jim. And if you're watching this on YouTube, click down here somewhere. There's a button that says Show More. Click that, and you will see the show notes. And while you're on YouTube, if you're on the YouTube channel, don't forget to click the like, subscribe, and bell icons so you can be notified when new episodes are released. If you're listening to this in the car, on the treadmill, or wherever on your podcast app, be sure and subscribe to the show so you'll automatically receive new episodes. We release new episodes on the second and fourth Tuesday of every month. Phil Zarrow, Jim Hall, thanks again for being my guest today on the Reliability Matters podcast.
And Mike,
great to see
Mike,
you.
one bit of parting technical advice.
Yes.
I know you're
going to do this. I know you're going to do this.
Like my brother.
Point the other way, Jim.
Yeah.
Point the other way. There you go. And Phil, you point the other way.
I know. He's over here somewhere. We're already
there. We go.
Like Mike either. Yeah.
So basically, don't solder like any of these guys.
That's right. Yeah.
Because if you do, you're going to hire these guys.
Yeah. Have a good time.
Right. Good seeing you guys.
Thanks again, Mike. We really
Good seeing you, Mike. Thank you.
Take care.
You're welcome.
Thank you.
Well, that's another episode. Thank you for listening to or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app. Or if you're watching this on our YouTube channel, be sure to click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. Once again, a special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks again for being part of our podcast family. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. And I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.